Hi, this is Ms. Park. In this video, we will be factoring a difference of squares. So, difference of squares looks like this. It's a perfect square, so something that can be written as something squared, and then another perfect square, and a subtraction in between. So, a difference, meaning subtraction, of two things that can be written as something squared. So, an example would be a squared minus b squared. Or we could also pick x squared minus 25. Okay, x squared is the square of x, and 25 is the square of 5. So that's a difference of squares. Not x squared plus 25, because that's a sum of squares. All right, so it's only a difference of squares. And we saw before when we had expanding, if we took two brackets, so two binomials, a plus b and a minus b, if we expanded these, we would get a squared minus ab plus ba minus b squared. And ab and ba are the same, so negative ab and positive ba, they cancel each other out, and we're left with a squared minus b squared. So what does that mean? It means if we have two binomials, it's the same terms, but different operations. So one's a plus and one's a minus. So operations, one is plus, one is minus. That creates a difference of squares because the middle terms will always cancel each other out. So let's just do some examples of factoring. So we know that factoring is the opposite of expanding. So suppose I asked you to factor fully, okay, and I give you x squared minus 36, right? So if we look at the example with the a squared minus b squared, what happens is the two brackets are the a plus b and the a minus b. We're just going to go backwards. So we just need to know what is the a and what is the b. What is being squared? So over here, let me just change color again. So here, this is my a squared, and this is my b squared. So the a must be equal to the variable x, and the b must be equal to 6. So I can factor this into x plus 6, right, a plus b, and then x minus 6, a minus b. All right, and so that's how you factor the difference of squares. And so we can do more complicated expressions. So let's go and get another one. So let's get 4x squared minus 81y squared. Okay, we're going to factor fully. So we recognize that it's a difference of squares because the 4x squared can be written as something squared. That would be 2x all squared. It's 4x squared. The 81y squared can also be written as something all squared. That would be 9y all squared. So they are both squares, they're both perfect squares, and there is a minus in between. So that tells us it's a difference of squares. So I can factor that. My a is 2x, it's the thing being squared, so I'm going to put it in both brackets. My b is 9y, it's the thing being squared, so put it in both brackets. And one's a plus and one's a minus. And if you want, you can expand them out and see that the middle term will cancel out and you will get 4x squared minus 81y squared. Let's do a few more. So let's do, how about 9x squared minus 25? Is this a difference of squares? Well, it is, because 9x squared is just 3x times 3x. 25 is just 5 times 5. So in one step, I can factor this into 3x, 3x, 5, and negative 5. 5 and 5, one's a plus and one's a minus. That's what I meant to say. One's a plus and one's a minus. Okay, and that's factored. Can we do this with the area model? We sure can, because if you look at the area model, it's got the 4 compartments, okay, for the answer. 9x squared, and here's the 25, right? But there's no middle term, right? It's just 9x squared minus 25. There's no x term, which means that this box here and this box here, when we add them up, they must add to 0 because the middle term is 0. Okay, so I'm just going to write that over here. The middle term is 0. So you really only have 9x squared and negative 25. That's all we have. So 9x squared, how are we going to write it? Well, we could do 3x by 3x. The negative 25 would have to be 5 by 5. Now one of them needs to be negative. And now we check. 3x times negative 5 is negative 15x. 5 times 3x is positive 15x. When you add these together, you do get 0. And so that explains there's no middle term. So I can factor this into 3x plus 5 times 3x minus 5, which is the same thing that I got before. Okay, so feel free to use an area model if you want to, or you can just go straight to the brackets. Right, a couple more examples. Let's get a little bit more challenging now. Let's go 36a to the 4th minus 100a squared. Okay, we're going to factor fully. So first thing to ask is this a difference of squares? And it is, because this one here, this 36a to the 4th, could be written as 6a squared, the whole thing squared. Right? 6 times 6, a squared times a squared. And this 100a squared could be written as 10a, all squared. So it is a difference of squares. And I can factor it as a difference of squares. However, notice the first thing we should always be doing is look for a common factor. Okay, so I'm going to write over here, look for a common factor first. And I see that there is one. So the best thing to do is to take out the common factor first. That will make our number smaller to work with. Between 36 and 100, I think the only common factor I think is 4. Well, there's 2, but 4 is bigger. And then a to the 4th and a squared, I can take out an a squared. So this now leaves me with 9a squared minus 25. Okay, and this is the 4a squared is still outside. I recognize that 9a squared minus 25 is a difference of squares, so I can factor it like this. Okay, and now this is fully factored because none of the factors can be factored further. Suppose I didn't notice that I could take out a common factor. So then I would go, this question could be 6a, right? Remember 6a squared and 10a, so 6a squared, right? Put the 6a squared in each bracket and 10a over here. And one's a plus and one's a minus. Okay, and that would be factored because it's written as something times something. That is factored, but it's not fully factored because each one of these brackets has a common factor in it. So I got to keep going. So from the first bracket, what's a common factor? Well, definitely a 2 and also an a. Factor that out and I get 3a plus 5. Times, there's also a common factor in the second one. Now this is times. There's nothing in between. 2a, and that leaves me with 3a minus 5. And if I just want to rearrange this, this is all multiplication, so order doesn't matter. I can multiply my 2a by 2a first and write that out front, and then I still have those two brackets. All right, and now I am fully factored. And this is the same answer as above. Okay, so the good news is that even if you don't notice right away that there's a common factor, you can always factor it out later. All right, and so those are your examples of difference of squares. Would you like a challenge? A little challenge question here. So I'm just going to go back to my pen. Let's use a letter like, I don't know, n. All right, so let's do this one. 2n squared plus 5. Sorry, I meant 2n plus 5 squared. Let me take that squared out. Okay, 2n plus 5 squared minus n plus 1 squared. Is this a difference of squares? It is, because the first one can be written as 2n plus 5 all squared. That's a square. The second one is n plus 1 all squared. That's also a square. So what I can do here is I can factor. I'm just going to put big brackets. My a is 2n plus 5, so I'm going to put it in both brackets. My b is n plus 1, so I'm going to put that in both brackets. So notice what I have. If I want to write a squared minus b squared, a squared minus b squared, then this is my a, b, a, and b. And I'm going to put a plus and a minus. Right? So that's how we do it. Plus here and minus here. And now I'm factored because this is written as something times something. We got the two brackets there. This is factored. The only thing is we need to clean up inside the brackets. So this one's going to become 2n plus 5 plus n plus 1. I'll remove the inner brackets. This one is going to become 2n plus 5 minus n plus 1, but got to be careful because this minus needs to be distributed to both of them. Make it like that. And now I can add up everything and I get 3n plus 6 times n plus 4. And I'm still factored. Unfortunately, I'm not fully factored because the first bracket has a common factor in it. So I'm going to factor out the 3 and I get n plus 2 times n plus 4. And now this one is finally fully factored. All right. Two more. Just when I thought it was over. How about this one? 4x squared plus 100. Okay, so let's factor this. Is it a difference of squares? Well, the 4x squared can be written as 2x all squared. The 100 can be written as 10 squared. Is it a difference of squares? The answer is no, because in between is not a minus. Okay, so that is not a difference of squares. So I'm just going to write that over here. Not a difference of squares. However, it can still be factored because there is a common factor of 4. So all I can do is take out the 4, and the rest is not factorable. Last example, I promise. Okay, so this one is going to be 16w squared minus 49 over 81. Yes, fractions. Okay, check the fractions carefully. Are they perfect squares? Okay, 49 and 81 are both squares. They are squares of the square of 7 over 9. And the 16w squared is also a square because it's the square of 4w. So it is a difference of squares. So my a is 4w, write them in both brackets. My b is whatever the square root of 49 over 81 is, which is 7 over 9. One's a plus and one's a minus. Okay, and there you have it, difference of squares, including challenge question. Hope that was helpful. Keep practicing. Thanks for watching.